Okay, ladies and gentlemen, I'm going to answer the question 17 from section 3.2. It says 10 identical is important. 10 identical playing pieces are placed on a 5x5 game board. On a 5x5 board, there would be 25 places where you could place these pieces. So, in how many ways could 10 playing pieces be placed on the board if there are no restrictions? Well, pretty straightforward, really. There are 25 locations. We are going to choose which 10 of them will have playing pieces. It's combination rather than permutation because it doesn't matter what order we place them in, just which spots are chosen for game pieces. So 25 choose 10. That's about 3,268,760. Now, part B says, in how many ways could 10 playing pieces be placed on the board if there must be 2 pieces in each row? Well, that kind of turns us into sort of 5 separate scenarios, 5 separate events, each of which are independent of one another. So we have 5 spots in the first row from which we must choose 2. And we have 5 spots in the second row from which we must choose 2, etc. So we could basically say 5 choose 2 times 5 choose 2, etc. Or you could say 5 choose 2 times itself 5 times. Now 5 choose 2 is, let's see, 5 times 4 is 20, divided by 2 is 10, so that's really 10 to the power of 5. That's about 100,000. So there are 100,000 ways that the pieces could be placed on the board if there must be 2 pieces in each row. Now, part C, describe how the results would change if the playing pieces were all different. Remember, at the beginning of the question it said that the pieces were all identical, but if they were all different, if you actually had 10 different playing pieces, then I guess you'd have to establish the order of those 10 pieces. So instead of this original calculation where we did 25 choose 10, well, for part C, I guess the order would matter. So in that case, I would say 25 P10. That would be arrangements where order mattered. And that's a pretty big number. That's 1.186 times 10 to the 13. How much is that anyway? I guess that's about 12 trillion ways if all the pieces were different, and in other words, if order mattered. Hope that helps. I know there's no answer to question 17 in the back of the book. That's how I would solve that one.